The sides of a square are 8 centimeters long. A new square is formed by joining the midpoints of adjacent sides, and two of the resultant triangles are shaded. Okay, so every time we are doing that, this process is repeated 5 more times to form a right-handed to form the right hand diagram below. Okay, this diagram. Find the total area of the shaded region in the right hand diagram above. Now look, what you have to understand in this before you start attempting it, I'll just give you one small hint. They are asking total area. Okay, it means that you have to work on area as a sequence, as an arithmetic sequence most probably. Okay, and you can see that the area is reducing because the shapes are getting smaller. Okay, so from the first figure, try to find area of this. Apply the logic to the second figure also. Try to find this area. And since it is an means it will be an arithmetic progression. Okay, so you need not even do the third area. You need not even find the third area. You should just know that how many terms are there. Like you can count how many terms are there. So this is second, then third, then fourth, then fifth, then sixth, because it is given 5 more times. This is the first time. After that, inside that, it is 5 more times. Okay. Now give it a try. I'll give you 2-3 minutes. Okay. Whatever you can attempt in that, then we will discuss it together. It is not necessary that this will be an arithmetic sequence only. Okay. I said that it looks like arithmetic sequence, but after solving that only you will get an idea. So let us keep it fixed over here. Always try to find 3 terms to determine whether it is an arithmetic or geometric sequence. Okay. Or else there is one more way with which you can get a hint. Find the total area of the shaded region if the process is repeated indefinitely. Indefinitely means this can be an infinite geometric sequence. These are like speculations. After reading the question, you are getting some hints. Okay, try. Okay.
So will shaded area be half of that?
Shaded area will not be even half of that, because if you look at this triangle, this is 8. Okay, so half of that will be 4. Just focus on one of the triangle. Okay, this will also be 4. How will you find area of a triangle? It is half base times height. So 4 times 4. Okay, and then you will just twice it out, because there are 2 such triangles. You don't need not find the whole area and then from there you subtract few things. You better focus on that shaded part only. So that will give me 16. Okay, so my first term of the sequence is 16. Is that clear?
Yes, sir.
Now, if you look at the next sequence or the next figure, this next figure, what is the length of the side of this? This is how much? You have to apply Pythagoras theorem to get this length. Okay, so that will come out to be 4 root 2.
Yeah.
Okay, when you will apply Pythagoras theorem, you are free to use calculator, so try to do all such calculations faster. You need not even show that. So that will be 4 root 2. Okay, now what I will do, I'll just create a small table. Okay, in that table, what I will be doing, over here, I'll be writing the values of n as 1, 2, 3, and 4. And here I'll be writing the term values. Like when n is equal to 1, then it was 16. Okay, when n is 2. So when it is 2, let us look at this square. Okay, this square. If you focus on the triangle which we have to find the area, this triangle, the base and height of this triangle will be half of 4 root 2. That is 2 root 2. If it is clear, I will move ahead. If not, I can tell again. Is it clear? 2 root 2.
No, sir, how did you get there?
Okay. Are you clear with 4 root 2?
Yes, I'm clear with that.
Okay. So what is half of 4 root 2?
Okay, 2 root 2.
Okay. Because it is said in the question that a new square is formed by joining the midpoints of adjacent side, and that is repeated. Okay. So that will be 2 root 2. So half base is 2 root 2. Height is also 2 root 2. And that will be times by 2. So 2 and 2 is cancelled. 2 root 2 times 2 root 2 is 4. 2s are 8. Okay. So my second term is 8. Okay. Now from the question, if you have read this part clearly and if you have gotten hint that yeah, this is a geometric sequence, then you need not work on further areas. You can predict them. But still, if you want to see, you can just check for one more. Okay. So like 2 root 2 and 2 root 2, if you look at this triangle, then what will be the hypotenuse for that? Okay, what will be the hypotenuse for this triangle?
So the sides was 2 root 2, right?
Side was 2 root 2. Side was actually 4 root 2. Then we half it up to get 2 root 2. Okay.
Yeah,
And
so it would be
now the hypotenuse
yes.
of that triangle is acting as a side for the internal square. We are going into the third layer now. So 2 root 2 whole square plus 2 root 2 whole square, that is equal to, let's say that side is A. So that is 4 2s are 8 plus 8, 16. And that will be 4. Okay, that side will be 4. I'm talking about this side. Okay, this is 4. You can see in the diagram I have written with green. Okay, so the third layer square is of side 4. We need to half it up. So the triangle which we will get from there will be having base and height as 2. So I'll just do it here. Half base into height will be the area of that triangle, and we need to twice it. So that will give me 4. So my n is equal to 3 is giving me 4. 3 terms are enough to prove that this series is a geometric sequence. Okay. If you have read part B of the question, that was actually enough to understand it is a question of geometric sequence. But since we are doing it very first time, all these type of questions, it is better to play safe. Okay, but when you will be practicing such questions, then you will be having some experience. So next time onwards, you need not even find the third term. From the two terms, you can get the common ratio. 8 by 16 is the common ratio. That is 1 by 2. And just get the next term by reducing it by half. Means just divide them by 2 and you'll get the terms. Okay. So now we have got a geometric sequence whose terms are 16, 8, 4, 2, and so on. How many terms are there? So we can see here that 5 more means there will be total 6 terms for which we have to find the sum. Okay, and by the way, this 16, 8, 4, 2, these are areas. We have already calculated the areas of this triangle, which are the terms of geometric sequence. So I need to find sum of 6 terms. The formula used for Sn will be a 1 minus r to the power n over 1 minus r. This is what we usually use when the value of r is between 0 to 1. In this case, r is 0.5, 1 by 2. So I'll be using this. So it will be 16, 1 minus 0.5 to the power 6 over 1 minus 0.5. Rest of the work will be done by calculator. Solve it and give me the answer. 31.5 centimeters square is the area. What else they were asking? Find the total area of the shaded region if process is repeated indefinitely. So the formula for infinite terms of a sequence, of a geometric sequence, is a over 1 minus r. We have all the values, so we can definitely calculate. So S infinity is equal to 16 upon 1 minus 0.5. That is 16 upon 0.5. It will be 32. Now this is very weird. If you notice, sum of first 6 terms is 31.5 and sum of infinite terms is 32. Is it practically possible?
Yes, sir, because we see how like it keeps reducing by half, so I think it's possible.
Yeah, because when we say infinite terms, so we usually ignore the higher terms because they will become smaller, smaller, smaller. Okay, you can see few terms here only. Like if we just keep on writing these terms, then these are the first 6 terms. Okay, then 0.5 divided by 2 will be 0.25, then 0.125, then it will further be divided, it will be 0.0625.
2.5, I think.
Yeah, and then it will become more and more smaller as we will just keep on getting the higher terms. So effectively the sum of infinite terms is obtained by initial 8-10 terms only. Okay, this is not a concept, this is just an observation. So that's why it is fairly possible to have infinite sum as this one. Okay, assuming that all other terms are very small to be, we can ignore them.
So I have a question.
Yes.
Why did you do 160 over 0.5?
Okay, it is 16 over 0.5. Then I removed the decimal. So 10 was added over there.
Oh, okay. I didn't see that.
Yeah, that was actually a manual step. So you can directly do 16 by 0.5 and you'll get the
Yeah.
same answer directly. This question is of 14 marks in total. And all parts will be connected. Question is lengthy, but it is easy. It is not that difficult. So what is the common ratio?
So is it just minus 1 log? No, what is it?
Okay, what do we do to find the common ratio?
So I think what we do is,
So we divide U2 with U1, but there's
Yeah.
a variable in there.
yes, so I think I know what to do.
Okay, tell me.
So 3 log x base 3 can also be written as log x raised to power 3 base 3.
Okay, wait.
What we
I'll
do,
stop you in middle only because that is a complicated way. Okay, I'll tell you
how
the
it
most
works, right?
easiest way. Like, look, you should be clear with the formula first that what will give you that R. Okay, like as Madison said, it will be U2 by U1. Okay, so we need to just do 2 log x
Over
to the
3,
base
right?
3 over 3 log x to the base 3. If you
Will be
observe
2.
carefully, they will
Right?
be cancelled.
Yeah.
Okay, so you need not apply any property of log. You will directly get the answer as 2 by 3.
Yeah.
Is it clear?
Yes,
Yes.
sir.
Maybe in the second part, you have to apply some, you have to think of applying some property of log. Okay, Raghav, is it clear?
Yes, sir.
Eventually, if you will convert now, you were applying base change formula. Okay,
Yes, sir.
then also it will be cancelled. So no need to even do that. So that was part A. Now in part B, we need to show that the sum of infinite sequence is this. So for that, what we need A and we need R. We need the first term and common ratio. One more just point of revision. Infinite sequence is possible only when R is between 0 to 1 or R is less than 1. that we have discussed in our lectures also. For
Yeah.
the values where r is greater than 1, it is not possible to find sum of infinite sequence. Okay. So for every question, you should always cross-verify, cross-check that, yeah, it is less than 1, so it is fairly possible. I'll be waiting for the answer.
So I got 3 log 3x by 1 minus 1.5.
Okay.
3
3
log x
log.
base 3 by 1 minus 1.5.
So 1 minus 1.5, that is wrong, no? Because
No,
1
it's not
minus
1.2,
r.
but
Okay.
yeah.
So this is a very straightforward question where 1 minus 2 by 3 will become 1 by 3. And we have 3 log x to the base 3 over 1 by 3. That 3 will go at the top and that will become 9 log x to the base 3. Clear to everyone?
Yes, sir.
Rajveer, any doubt? Given us that it is an arithmetic sequence, find the common difference. So common difference is, how do we get the common difference?
U2 minus U1.
Yes, u2 minus u1. Okay, so you may have to apply some property of log, just give it a try. So I'm just doing it here. You guys can carry on and then you can check your answers. So common difference will be u2 minus u1. That will be log of x over 3 to the base 3 minus log of x to the base 3. Now you have to be very particular about what properties of log we have to use. That will come gradually when you will see such questions. Okay. Just observe it carefully that we already have minus log x to the base 3. Okay, which is ready to be cancelled if I have plus log x to the base 3. These are all analytical parts which you should be able to think when you are solving. So what I'll do, I will not apply base change formula. Okay, if you will apply base change formula, it will unnecessarily be expanded and then you will end up getting same answer, but high chances of making a mistake. So I'll be just applying this property of log. If I have log of a by b, it will be log a minus log b to whatever base it may be. Okay, I am keeping base as 3 only for time being. If required, I'll do it later. So it will be log x to the base 3 minus log 3 to the base 3 minus log x to the base 3. Okay. It is better to always show which property you are using. Log x to the base 3 minus log x to the base 3 is gone. Log 3 to the base 3 will be 1 and it is having a minus sign. So my final answer will be minus 1. Okay, just look at it if there is any doubt in any step. It was more over that thinking part, which if it is done correctly, you will not be struggling in such questions. So the first term is log x to the base 3. Common difference is minus 1. Sn formula for an arithmetic sequence is n by 2, 2a plus n minus 1 d. So 6 by 2, 2 times of log x to the base 3 plus 6 minus 1, 5 times minus 1. This will be 3 multiplied inside. It will be 6 log x to the base 3 minus 15. This is what they were asking. So yeah, we are done with it. It is always recommended to write down the formula. Okay, so please write down the formula for Sn which you are using. And yeah, the next test is okay. Last part of the question, given that S6 is equal to 1/3 of the sum of infinite geometric sequence. We have found both of them. We need to just equate them. So sum of infinite geometric sequence is 9 log x to the base 3. 9 log x to the base 3. And S6 is 6 log x to the base 3 minus 15. Question says that S6 is equal to 1/3 of the sum. So S6 is equal to 1/3 of this. I have just framed it like an equation. You guys can quickly solve it. You need to take anti-log in such questions to get the value of x. Okay, anti-log is you need to just raise that base to the power of other number, the opposite number. So just give it a try from here and get me the x value within a minute. It will not take more than that. So in such cases, you have to always treat this log x to the base 3 or similar term equivalent to some x or some k, something like that. Okay, so to make it look easier, I'll just write down over here. So 6k minus 15 is equal to this 3 and it will be 3k. So it is like a linear equation we have to solve that will give me 3k is equal to 15 and k is equal to 5. Okay, this should be your thought process when you are solving such an equation. Okay, so what I'll do, I'll just solve it like this. 6 log x to the base 3 minus 3 log x to the base 3 is equal to 15. 6 minus 3 is 3 log x to the base 3 is equal to 15. Log x to the base 3 is equal to 5. And then I will take anti-log. Anti-log means I have to raise this base to the power of other side number. So that will give me x is equal to 3 to the power of 5. We can leave the answer in this form as it was asked in the question. Giving you answer in the form of a to the power p, where a and p both belong to this z means integer. Okay. This sign which looks like e, this sign means belongs to. These are the terms which we usually use in set theory. Okay,
Yes,
so till answer, is it clear to everyone?
yes, I almost got this, but the way I did it was
Find their sum, which is divisible by 9 means it is for sure an arithmetic sequence. So between 20 and 300, so the nearest multiple of 9 after 20 will be 27. It will start with 27, then 36, and so on. And it will go up to, if I just divide 300 by 9, what remainder I am getting? 9 threes are, then 9 threes are, 3 is the remainder. So 297 is the last term. Okay, is there anyone who have doubt how I got 297 as the last term? Why we have to get last term? Because we need to get the total number of terms. Okay, right now we don't have that. So now 297 will be treated as the nth term or the last term, and we are going to use this formula. an or un is equal to a plus n minus 1d. So that will be equal to 27 plus n minus 1 times 9. 297 minus 27, it will be 270 is equal to n minus 1 times 9. 270 divided by 9 will be 30 is equal to n minus 1. The value of n will be 31. Now to get the sum, we can use n by 2 a plus L formula because we have first and last term. So n is the total number of terms, 31 by 2. A is the first term, that is 27, and last term is 297. Rest of the work can be done by calculator. Just solve and try to get the answer. So the answer is 5022. Part B and part C of these questions, I am skipping it for now. We will be doing it in the next class because we haven't done sigma notations. Okay, so first I'll teach you sigma notation and then we will do these type of questions. So for now you can leave it. It's fine. And yeah, if any one of you can means you know sigma notation, then you can definitely try on your own. I will be attaching few more